Hey there, Mr. Sutton here. This is the Pre-Cal Honors 3-5 Part 2 homework solutions on rational equations. To solve this rational equation, we need to first get rid of the x's in the denominator. So to do that, I'm going to multiply everything by the LCD, the least common denominator of this equation. The LCD is going to have everything I need to cancel out each of the denominators. So we need an x minus 5 in there, and we also need a 2. And if I have that, that's going to be enough to cancel out everything I want to. So at this point, let me multiply all of my numerators by the LCD. So this 3x minus 7 is getting a 2x minus 5 up there with it. This x is going to share the numerator with another 2x minus 5. And we're going to have equals 8 over x minus 5 times that LCD as well. Now's the fun part where I go through and cancel out whatever I can. X minus 5s are canceling there. 2's are canceling in the next fraction, and x minus 5's cancel in that last fraction. Going back through and cleaning stuff up without those denominators, we've got 2 and a 3x minus 7. I can distribute that. So we've got 6x minus 2 times 7 is 14. Next, I have an x minus 5 times an x. So that's going to be, x squared if I distribute that, minus 5x. And over here, I've got a 2 times an 8, giving me a 16 for the equals. All right, let me get everything on one side, because I think I can factor this thing. So the x squared can stay where it is. We have a 6x minus a 5x. That's just a plus x. And we have a negative 14, and I can subtract this 16 to be over there with it. So that'll be negative 30 equals 0. Now I need numbers that multiply to negative 30 and add up to 1. So if we have negative 5 and plus 6, that would do the job. X minus 5 and x plus 6. Going through and zeroing those both out, I see that x equals 5 or negative 6. And just double checking to make sure neither of these make anything undefined in the original equation, because I have to check for extraneous roots. If I plug 5 into the original, I see that I have 5 minus 5 in the denominator, which means I'm dividing by 0, and that's no good. So 5 makes the original undefined, and we're going to have to cross that off. How about negative 6? Well, negative 6 minus 5 is fine, and still fine over here. This 2, there's nothing to worry about there. So negative 6 is still a good answer. For this rational equation, I'm trying to solve this thing and check for any extraneous roots that there might be. So the first key to this one is getting the x's out of the denominator, and I can do that by multiplying the entire equation by the least common denominator, by the LCD, to cancel out those denominators. Before I can do that, though, I'd like to factor this x squared minus 16 so I can see what all the factors are. So this is going to be the difference of two squares, so I can use my plus minus shortcut and square root those to get x plus 4 and x minus 4. And now I see that I actually only have two unique factors for my LCD. I need an x minus 4, I need an x plus 4, and if I have those, that will also cover having both of them at the same time. My LCD is going to have everything I need to cancel out each of the denominators. So now that I've got that, I'm going to multiply all my fractions by the LCD. So first fraction with a 3 up top gets the LCD up there as well. And we're just multiplying into the numerators now. So now we also have a 2 with the LCD up there. And this last fraction, we have a 14 sharing the numerator with an LCD. Now we go through and cancel out whatever we can. First fraction, it's the x minus 4s. After that, it's the x plus 4s. And in the last fraction, this is the jackpot. Everything's canceling except for the 14 up there. So going back through and cleaning up this mess, we have an x plus 4 and a 3 in our first fraction. Distributing that 3, we have a 3x plus 12. In the next fraction, we have an x minus 4 and a 2 that's kind of hiding over there. So that's a 2x minus 8 if I distribute. And we have just a 14 on the other side of the equals. Now I notice that we have only linear terms and constants, only x's and numbers. So if I get the x's on one side and the constants on the other, I should be able to solve this pretty quickly. So let's do the x's on the left side. For that, we just have to combine like terms. We have 3x and 2x giving us 5x. For the numbers, we're going to combine and then move stuff over to the right side. So 12 minus 8 is 4. And if I subtract 4 over to the right side, 14 minus 4 gives me 10 over there. So dividing by 5, I have x equals 2. And just double checking, if I plug 2 back into the original or the factored version of the original, 2 minus 4 isn't 0, 2 plus 4 isn't 0, so I'm not getting 0 in any denominators. I'm not making anything undefined if I plug 2 back in. So we're good. 2 is an acceptable answer. For this problem, we need to solve for x and then make sure there's no extraneous roots. To do that, I want to get x out of the denominator, get rid of all the fractions really. So I'm going to multiply everything by the least common denominator after I find it. The LCD is going to have everything I need to cancel out my denominators. So we need an x minus 3 and a 2 in our LCD. And then I'll just multiply that expression by all of my numerators. So we have 4x minus 7 with a 2x minus 3 sharing the numerator there. This x is going to be kept company by the LCD as well, which I'm putting in red there. And we have an equals 5 with an LCD up there on the other side. All right, let's go through now and cancel out those denominators. So x minus 3's are gone. These 2's in the second fraction can go. And in the last fraction, the x minus 3's are gone. Going back through and cleaning up whatever's left in the numerator, I have a 2 and a 4x minus 7 in that first one. Distributing that gives me an 8x minus 14. For the next fraction, we have an x minus 3 and an x. Distributing my x gives me a plus x squared minus 3x. And then over on the right side, we just have a 2 times 5 giving us a 10. This is a quadratic with just an x squared, 1x squared. So I'm pretty confident I can at least try to factor this thing if I can move everything over to the left side. So let me keep the x squared where it is. And on the left side, I have an 8x and a negative 3x that I can combine to give me 5x. I also have a negative 14. When I subtract this 10 to get it over here with the negative 14, now I've got a negative 24 and an equals 0. So are there numbers that multiply to negative 24 and add up to 5? I believe there are. If we have negative 3 and positive 8, that would do the job. So x minus 3 and x plus 8 equals 0. Which means if I go through and zero out each of these, we've got x equals positive 3 and negative 8. Now I do need to go back and double check to make sure neither of these makes the original undefined. Taking a look here, if I plug 3 into the original, I've got 3 minus 3 in the denominator, which gives me 0 in the denominator. 3 then will make the original undefined, and we have to cross that off. It's an extraneous root. Negative 8, if I plug that in, well, negative 8 minus 3, that doesn't cause any damage, and this 2 is fine, so negative 8 is still a good answer. For this one, we need to solve this equation and then maybe check for extraneous roots. So before I go any further, I've got all these denominators. I'd like to get rid of them by multiplying by the least common denominator. To figure out what that is, I'm first going to factor this x squared minus 3x to see what kind of factors we're dealing with, because all the factors need to end up in the LCD. So here I can just take out an x, leaving me with x minus 3 down there. And that's the only real change between one equation and another here. I see now that my LCD at the very least needs an x and an x minus 3 for that very first denominator. Now moving on, I see that I've got an x in this denominator, but the x is already covered. We have an x minus 3, but that's already covered from that first one. So this LCD has everything I need to cancel out each of these denominators. So I'm sticking with what I got here. Now I'm going to multiply all of my numerators by the LCD. So we have a 14 times the LCD over the x and x minus 3, minus an 8 times the LCD up there. And now my last fraction gets multiplied by the LCD as well up there. Now I'm going to go through and cancel out whatever I can. For my first fraction, the x and the x minus 3 both cancel, which is really nice. The next fraction, it's just the x's canceling. And this last one, it's just the x minus 3's canceling. All right, there we go. I made my canceling only include the x minus 3. Let's go back through now and clean things up. So after the dust settles on this first fraction, all that's left is this 14. For the next fraction, we had an 8 and an x minus 3, which I can distribute. I also have this negative to be careful with here, so I'm going to think of this as negative 8 being distributed. So negative 8 times x is negative 8x. Negative 8 times negative 3 is positive 24. And now over here we have an x, we have a negative 10, so that's a negative 10x. And then on the left side, I can combine the 14 and the 24 for a 38. And I can also add the 8x over to the right side. That'll be negative 2x over there. And then finally, to get x by itself, let's divide by negative 2. So that's going to be negative 19. But before I call it a day on this one, let me just double check and make sure that's not going to give me 0 in any of my denominators. Looking in the factored version of the original here, I see that if I plug in negative 19, I'm good here. I've just got a negative 19 times a negative 22. That's not 0. The x is going to be fine. Negative 19 minus 3, that's fine. So that doesn't make anything undefined, meaning this is a good final answer.